A concrete truck travels 350 kilometers to deliver concrete to a construction site. So here I wrote V1 as the truck speed during the delivery trip, and V2 as the truck speed during the return trip. After unloading the concrete, the truck travels back to its starting point and is now lighter, letting it travel 8 kilometers per hour faster. How fast did the truck travel before and after the delivery if the total round-trip time was only 14.4 hours? So here I'm going to write T1 plus T2 equals 14.4. T1 is the time it took to make the delivery trip, and T2 is the time it took to make the return trip. So adding them together makes a total round-trip time of 14.4 hours. In here, it looks like we're going to have to relate T1 and T2 to V1 and V2. So knowing that the speed will always be equal to the distance divided by time, I'm going to have to write V1 is equal to 350, which is the distance, divided by T1. And the same also goes for V2, which is equal to 350 divided by T2. But since we have the equation of T1 plus T2 is equal to the total time of 14.4, in order to plug in whatever we have into this equation, we need to express the time in terms of speed rather than the other way around. So here I'm going to write T1 is equal to 350 divided by V1, and T2 is equal to 350 divided by V2. But remember, we could also express V2 in terms of V1, because we know that V2 is faster than V1 by 8 kilometers per hour. So I'm going to write here V1 plus 8 in place of V2. Alright, so now to solve for an unknown, we need to reduce the number of unknowns in an equation down into one unknown. So right here, you can see that we have two unknowns in an equation, which is T1 and T2. So that will only take us nowhere, and that is never going to work. But since we already have the equations for T1 and T2 in terms of V1, we can just plug those into our equation to reduce the number of unknowns into just one, which is V1, which happens to be the unknown that we are looking for. And now, all we have to do is simplify this equation and solve for V1. And now you can see that we have lots of fractions in the left side of the equation. So what we need to do is to multiply the whole equation by the LCD, which is V1 multiplied by V1 plus 8. So getting rid of all the fractions, we get 350 multiplied by V1 plus 8 plus 350 V1 is all equal to 14.4 multiplied by V1 multiplied by V1 plus 8. And now, multiplying everything we can, we get 350 V1 plus 2,800 plus 350 V1 is equal to 14.4 V1 squared plus 115.2 V1. Now, combining the V1 terms on the left side, we get 700 V1 plus 2,800 on the left side. And moving everything to the right side, we have 0 is equal to 14.4 V1 squared plus 115.2 V1 minus 700 V1 minus 2,800. And now, we're going to combine both V1 terms, and we end up with a quadratic equation of 0 is equal to 14.4 V1 squared minus 584.8 V1 minus 2,800. And now, all that's left for us to do is to use whatever method we have available in order to solve for V1. Since we have decimal number coefficients, it's going to be more convenient to use the quadratic formula. For our coefficients, we have b to be negative 584.8, so I'm going to have to write that down. For a, we have 14.4. And for c, we have negative 2,800. And last, we have another a in the denominator, so the denominator becomes 2 multiplied by 14.4. And now, simplifying our quadratic equation, we end up with two values for V1, which are 44.9 and negative 4.35. Note that the velocity cannot be negative, otherwise the truck would be driving backwards. We cross out the negative 4.35 and take in 44.9 as our answer. So now, V1, which is the delivery trip speed, is found to be at 44.9 kilometers per hour. And now solving for V2, since we know that V2 is 8 kilometers per hour faster than V1, we just add 8 to V1. And we end up with V2, which is the return trip speed, being at 52.9 kilometers per hour. And there we go. That concludes the video. So if you didn't get all the steps, make sure to go over the video again.